All right, next we're going to take a look at adding and subtracting these polynomials, these expressions with many terms and positive exponents. So we're going to take a look at three different parts, just adding monomials, and how do we do that? And we're going to take a look at adding two polynomials when there's many terms in each polynomial, and then finally subtracting polynomials. So let's start by just reviewing how to add monomials. Now, you may not think you've done this before, but you have. Adding monomials is really just the same thing as adding like terms. We want to find the terms that have the exact same variable parts, which means they have to have the same variables raised to the same powers, and then we can add the coefficients together. For example, we have 15m cubed plus 6m squared plus 2m cubed, and I notice that I have two terms that have m cubed as the variable part. So those are the like terms. Those are the ones that we want to add together. And when we add 15 and 2 together, we get 17 as the new coefficient. So it's 17m cubed plus 6m squared. Now I can't add anything else together because they're not like terms. It's the same thing as having x's and y's. You can't add those together either. So your variables must have the exact same exponent in order for you to add the coefficients together. In example B, we take a look at that and look to see if there are any like terms. I see that I have 3x squared. Are there any other x squareds in this problem? Absolutely. It's minus 7x squared. So we could combine those. 3 minus 7 is negative 4. And then we also have like terms as constant terms. Just regular numbers are still like terms too. So we can combine those by adding 5 and 12 together to get the 17. So we had negative 4x squared plus 17. So that's how we add monomials. It's really just like adding like terms. Now, for adding polynomials, kind of the same, but we're still looking for like terms. Anytime you're adding polynomials, you want to start by just taking the two polynomials and rewrite it without parentheses. So I'm going to take my first polynomial, 2x squared, and yes, it says minus x. I'm going to write it as minus 1x because I might need that little number later. And then it says that I'm adding x squared, and I'm adding positive 3x, and I'm adding a negative 1. Whoops, let's make that a minus then. So there's all 5 of my terms listed. I want to look for and identify any like terms, starting with the term that has the largest power. Because remember, we always write our answers in standard form. So I want to make sure that I have, well, and then I'll have to rearrange it later. Start with the terms that have the largest exponent. So I have 2x squared plus 1x squared. That's going to give me 3x squared. Notice I add the coefficients together, but I don't add the exponents. The exponents stay the same. Then I want to look for my next type of like term. I have just my regular x's, like x to the first power, and I actually have 2 of those terms that I can add together. Negative 1x plus 3x, well, let's see, negative 1 plus 3 is positive 2, so that's going to be positive 2x. And then I just bring that constant term down at the end. So 3x squared plus 2x minus 1. The next example, do it the same way. Start by rewriting all the terms without parentheses. And I can only do this when it's addition, by the way. I can just drop the parentheses in the addition problems, but not the subtraction problems. I'll show you how to do that next. I put my little coefficient of 1 where it's needed. And now I'm looking for the terms that have the largest exponents. I see I have b to the 5th power as the largest power here, largest exponent, so degree 5. So when I add my coefficients, I have 4 plus 3, which is 7, and then, oh, I'm taking away 7. 7 minus 7, or 7 plus negative 7. So actually, those are all going to add up to 0, which kind of makes them all just cancel out. I don't have any of them anymore. So what's left over would be anything to the, or b to the 1st power. And I take those 3 terms and add them together. 8b plus 6b is 14b, plus 1 more is 15b. Now, when we look at subtracting polynomials, it's a little bit different with subtracting. I start with my first polynomial, and now I need to subtract the second polynomial. And now it's just a matter of combining like terms. So I take my x squared terms and combine them, keeping in mind I have to use that sign in front of the second one. And let's see, 2x squared take away 4x squared is negative 2x squared. Since my only term left is a constant term, I bring that down at the end. And the way that I did that is I made sure that my answer was already written in standard form. For my last example, I have my first polynomial, so I just take the parentheses off the first polynomial. But now I have to show that I am subtracting everything in the second polynomial. So it's subtracting 3a to the fourth power. It's subtracting negative 3a. So it would kind of look like that. Subtract negative 3a. I don't like it looking like that. I know that subtracting a negative is going to actually make this positive instead. And then finally, I'm subtracting positive 1. So basically, I change all of the signs in that second polynomial. If you look carefully, in the polynomial, it was 3a to the fourth power, but I wrote it as minus 3a to the fourth power. It was minus 3a, but I wrote it as plus 3a. And instead of a plus 1, I'm subtracting 1. Now I have my list ready to go. I don't have to think of it as subtracting anymore. I just combine like terms. So I'm trying to find my terms that have the largest power, the largest exponent. I see that that would be 1a to the fourth power minus 3a to the fourth power is negative 2a to the fourth power. Then I also have, let's see, a to the first power and a to the first power. I can combine those. Negative 2 plus 3 is positive 1, so that's going to be 1a. And then I just have the minus 1 left over at the end. There's nothing to combine it with, so we just bring it down as that constant term. And the way I wrote my answer is I made sure I had the term with the largest exponent first, all the way down to the smallest exponent of 0. So it's already written in standard form. So when you add two polynomials, you literally just drop the parentheses and combine like terms. When you are subtracting polynomials, and you'll see the subtraction sign between the parentheses, you have to apply the subtraction to everything in the second set of parentheses. Then you can combine like terms.